When you stand at the base of a modern skyscraper, the scale is hard to comprehend. At the highest floors, these structures face intense atmospheric conditions, enduring wind speeds that can match a severe hurricane. It is easy to look at a tower of concrete and steel and assume it is built to be an unyielding fortress. Earthquake would cause the steel and concrete to snap. Think of a tall oak tree. During a violent storm, the tree survives because its trunk yields and bends with the force, rather than fighting it. Swaying isn't a mistake in the design. It is the core survival mechanism that keeps these massive structures from breaking under extreme stress. As wind hits a square tower, it creates alternating whirlpools of air that spin off the back corners. These swirling currents actually pull the structure from side to side. If a building is pulled back and forth too aggressively over time, that repeated movement can lead to metal fatigue and eventually tear at the structure. Long before the steel structure gives out, the people inside would feel the movement. Constant swaying would cause severe motion sickness, making the highest and most expensive floors uninhabitable. This creates a difficult engineering puzzle. A skyscraper must bend to survive the wind, but bending too much makes the building dangerous and useless for the people inside. The Taipei 101 tower sits in an area frequently hit by severe typhoons and active earthquakes. To stay standing, it relies on a masterclass in solving that swaying puzzle. Hidden between the 87th and 92nd floors is a 660-ton steel sphere, 18 feet wide, suspended by massive cables. This setup uses a principle called inertia, the simple fact that a heavy object naturally resists any change to its state of rest. This diagram shows what happens when a storm pushes the building's frame to the right. Because the suspended sphere is so heavy, its inertia causes it to lag behind, effectively swinging to the left side of the shaft. The pendulum acts like a massive anchor floating in midair. It uses its weight to actively fight the storm's push and stabilize the entire building. But the energy from the storm hasn't vanished. It's now captured in that swinging sphere. To stop the entire building from swaying, we have to find a way to get rid of that captured motion. At the base of the pendulum is an array of massive, liquid-filled shock absorbers attached to a protective steel ring. As the heavy sphere swings, it pushes a piston inside these cylinders, forcing a thick fluid through tiny gaps. The intense friction of the fluid squeezing through those narrow spaces converts the mechanical energy of the movement into heat. The building doesn't defeat the storm with brute force. It survives by secretly consuming the storm's energy and bleeding it off as harmless heat. Every physical structure has its own unique internal rhythm, the specific speed at which it naturally wants to swing back and forth, based on its height and materials. The pendulum's cables are precisely adjusted so its swing matches that rhythm perfectly, but moves in the opposite direction at the exact same moment. Because the sphere is always pulling left at the exact second the building is pushed right, the two forces fight each other to a standstill. This can reduce the total sway by up to 40%. This mechanism is far more than a simple weight. It is a precisely calibrated instrument designed to perfectly counteract the building's unique structural heartbeat. Today, this technology protects extreme megastructures globally, allowing them to stand tall even at high altitudes where wind forces are most severe. Not every building uses this method. Towers like the Burj Khalifa are shaped to slice through the wind, using their tapering profile to break up those air currents before they can pull the building side to side. But for many others, the solution is this hidden dance, facing a raging storm outside while maintaining a perfectly timed, calm internal rhythm. Modern skyscrapers are not static, lifeless monuments. They are active, breathing machines that constantly work with nature to keep our skylines standing tall.